Okay, so the second part of the question is the reading on the voltmeter is 1.64 volts. Show that the reading on the ammeter is about 20 milliamperes. Okay, so let me write the data first. That is 6 volt, and this is 1.64 volts. So it means if this is 1.64 volt, this is also 1.64 volts, and this is 1.64 volts, because in parallel the voltage remains constant, right? So and according to KVL, we know that the amount that you are supplying, this is the supply. The supply voltage is equals to the consumed voltage. So the supplied one is 6, and the consumed voltage here is 1.64. And what about here? We just have your V. So from here, I'm going to get 6 minus 1.64 equals 4.36 volts. Okay, this is 4.36 volts. Now I have here voltage and resistance, so I can easily find the current here, which is I equals V over R, 4.36 over 200, and it is going to be let me get it, 0.0228. Okay, so that is about 22 milliamperes. And that is exactly about 20 milliamperes. Okay, so why is it 20 milliampere and why it's so correct? Because if you see that the current here is coming out to be like this, okay, I, but here it is divided into two. So like one is moving this way. Okay, wait. Let me draw that again. So the current is actually coming out here, okay, and divided into two parts. One is going this way and one is going this way. So this is I1, this is I2, and now it is coming back here and rejoining again. And then it is coming here again as I. So I is actually the full current. So ammeter is measuring the total current of the circuit, not the individual component or individual circuit, individual current I1 or I2 for X or 100 volts, 100 ohm resistance. Remember that, okay? I1 is the current exclusively at only X. I2 is the current only at 100, but I is the current in the total circuit. Okay, is the total circuit of the current, and that is what we have done in B1. So what about B2? Determine the resistance of resistor X. Okay. So don't you think we can apply the formula KCL for solution of this? So that was the solution of B1. Okay. Yeah, B1, and now we are solving B2. So if you take a look of the diagram, you will see a gap between the tube and the tuning fork. And we have calculated the wavelength for only this part. And there is actually a total wavelength should be this much, right? So the total wavelength that we are actually calculating is less than the real one. So how does it going to change the frequency value, right? So frequency is actually V over lambda. So actual frequency, current, our wavelength is not actually the same as the one it should be, because there is a slight gap between the tuning fork and the tube. So our wavelength is decreased. Due to that, our frequency has been increased, right? So in actual, if we consider that gap between the tuning fork and the tube, then the wavelength will increase and therefore the frequency will decrease. Okay, so you just write that the wavelength measured is less than actual, because actual is actually gap plus tube length, right? Therefore, f is inversely to lambda. So f is decreased as lambda will increase after considering gap as well. Question number 18. Some types of glue can be hardened by exposure to ultraviolet light. One type of UV lamp contains mercury atoms in an evacuated glass tube. When a large potential difference is applied between the two electrodes in the tube, electrons move between the two electrodes. Okay. So remember in this diffraction question, I explained you that when you apply a very high voltage here, then the electrons are accelerated, right? So same is the thing that is actually happening in this question. If you read it closely, they are saying that when a large potential difference is applied, between the two electrodes in the tube, electrons move between the two electrodes because they're accelerated. These electrons collide with mercury atoms in the tube. These mercury atoms then emit photons. Okay, explain why the mercury atoms emit photons. So understand the principle of gas discharge tube. Okay, so these are the mercury atoms, and this is gas tube, and you applied a very high voltage like 5,000 volts. Okay, so when you apply a very high voltage, what will happen? The electrons are going to be accelerated to a very high speed, right? So say that this is electron coming in and striking it. Okay, so when the electron strikes it, what happens? High speed electrons deliver their energy to mercury atoms. Okay, and due to that, mercury atoms are excited and move to higher energy levels. Okay. And move to higher energy levels. So upon de-excitation, they come back to low energy levels and emit all the energy in the form of photons. Lower energy levels and release energy in the form of photons. Okay, so remember that, for example, if one shell has an energy like third shell is having energy like 100 joules, and first cell is having energy like 20 joules. So the emitted photon will have energy of 80 joules, because the difference of the two levels will be equals to 80 joules. And you write this as HF equals E3 minus E1. Okay. So the difference of the energy of the two shells or two levels will be emitted as the photon, and that photon will have that energy difference between the two energy levels. Okay, B. A technician is replacing the screen on the mobile phone. He spreads out a layer of glue over the phone surface and attach the glass screen. Okay, the glue is then hardened when exposed to ultraviolet light. The equipment used and screen dimensions are as shown in the following diagram. The intensity of the ultraviolet light received on the screen is 50 milliwatt per centimeter square. The glue takes 25 seconds to harden. Show that the total energy incident on the glass screen during this time is about 130 joules. Okay, that is the intensity question. First of all, you need to know that the intensity is power over area. So you need to know the power area, right? So the area is this much, and area is 0.0715 into, I'm just converting that into meters, 0.147. So answer is, okay, forget about that. We don't need to convert that into meters, just centimeter square is okay. And time is 25 seconds. Okay, and the intensity I is 50 into 10 raised to the power of minus 3, because it's milliwatt. So it's watt centimeter square. Okay. So now they're asking us to show that the total energy we need to calculate. So from here, power will be equals to I into A, right? And power is actually equals to work over time. And work means energy, right? So IAT, that is going to be current is, sorry, intensity is 50 into 10 raised to the power minus 3. Area is 105, and the time is 25. So it is going to be 131250 joules. And we need to show that 130 joules, right? So it is about 50 into 105 into 25. Yeah, it's about 130 joules. Okay. So determine the number of photons incident on the glass screen in this time. Wavelength of the UV light is 395 nanometers. So number of photons. Okay, so you know that the energy of photon is this, and this is just true for one photon. Okay, and if you want to know the number of photons, you just need to write NHF for n number of photons. Okay, and that is true for n number of photons. So um, energy you already know, which is 131.2 equals n is something that we need to find. H is 6.63 into 10 raised to the power minus 34, and F is going to be C over lambda. So F is just C over lambda. C is 3 into 10 raised to the power 8, and lambda is 395 into 10 raised to the power minus 9. So we're just putting it in here. 395 into 10 raised to the power minus 9. And when you calculate that from here, you know that the answer is going to be 2.6 into 10 raised to the power 20. So this number of photons will be arriving on the screen. So it means about 2,600 to 260 billion photons will fall on that screen by of the light. Oh my God, it's a huge number. Okay, so C. The potential difference applied between the electrodes and the UV lamp is increased. Explain this effect would have on the frequency of the UV light produced by the lamp. Okay, so you know, when potential difference will increase, so what will happen? Potential difference is actually responsible for the acceleration or the more speed of the electrons, right? So when potential difference is increasing, electrons are more speedy. Okay. So when electrons are more speedy, it means they have more kinetic energy. So when they have more kinetic energy, it means so more transfer of energy to mercury atoms upon striking them. Okay. So when more energy is transferred to the mercury atoms, they will be excited to even more higher energy levels. Okay. And when they're excited to even more higher energy levels, they will release photons with greater energy or frequency. Okay, because frequency and energy are directly proportional to each other. So that is actually the impact of rising the potential difference of the glass tube. So you're giving more voltage means electrons are accelerating more, they are having more kinetic energy, and with more kinetic energy, when they strike the gas tube mercury atoms, the mercury atom will be excited to even more energy, higher energy levels, and when they will de-excite to lower energy levels, they will release photons of greater energy. Okay. Suggest why the hardening time of the glue is reduced if the UV lamp is moved closer to the mobile screen. So it's quite obvious that when the lamp is brought closer to the screen, more number of photons are incident on the screen. So when UV lamp is brought near the screen, more number of photons are incident on a screen. Okay. So rate of energy transfer to screen by photons is increased. So when more energy is transferred in less time, so it means it will take less for the screen to get dried. Okay, so that is the end of Unit 2 walkthrough, and I wish you all the best and see you in the next walkthrough. Up till then, it's goodbye. Thank you.